Hi everyone, welcome to my channel. This is Leo and let's do some more Leetcode problems today. Today's problem is called Contiguous Array. We were given a binary array, nums. Binary means we have only 0 and 1, and return the maximum length of a contiguous subarray with an equal number of 0 and 1. Okay, so we're going to return a subarray length. Okay, so this reminds us of something like sliding window or PrefixSum, something like that. Okay, so yeah, let's take a look. So we have a nums array, which is consisted of 0 and 1. So the maximum length of this array with the equal number of 0 and 1 is 2, okay, as we can easily see from here. And for this one, the result is 2 as well, but we can have this subarray or this subarray. Okay, so that's basically how it works. So the brute force idea is to generate all subarrays and update the maximum length. Okay, so this will be very time-taking, as we have to keep two pointers, one starting from here, the other one pointing to the end of the subarray, and iterate all the way there. Okay, so this will result in n squared time complexity, which is not optimal. Okay, so we can think of something else. So if we think 0 and 1 are opposite, and we have something like, if we have a count, every time we encounter 1, we will record 1. And every time we encounter 0, we'll record it as -1. So 0, 1 becomes -1 and 0. Okay, so the first time we see 0 as the count or the PrefixSum is here. Okay, but before that we still have another one. Okay, so here in the -1, so before the array starts, the count is 0. Okay, but we now have a index of -1. Okay, so we don't count it in. And at this time, we can calculate the maximum length by subtracting -1 from the index of this number, which is 1. Okay, here, yeah, something like this. All right, so this is what we have for the PrefixSum. Okay, if you don't remember, I can tell you something about it. So let's say if we have something like 0, 1, 2, this is the count, okay, or the PrefixSum. 0 means we're starting, and 1 means we encountered a 1, 2 means we encounter another 1, and 3 means we encounter another 1, and then 2, that means we encountered a 0. That, by that time, okay, let me put it out here, 0. So by that time, the difference between this number and this number, which is this subarray, is what we're going to update, because we've seen this PrefixSum before. Okay, so this is pretty much like that. And if we have another 0 here, we will see if we have seen this count before. Okay, so here we have encountered the count, so we subtract this part, the index of this number, by this number. So we have a subarray of this, which is the equal number of zeros and ones, and the maximum length is updated to 4. Okay, so that's basically how this idea works. So When I talk about prefix sum, you naturally think of a hash map. Okay, so we're going to initialize the hash map first. So with the hash map, what we're going to put is this part. Okay, so let me write it out. The map contains something like prefix sum and the corresponding index. Okay, so what I will put into the map is 0, -1, because if we ever encounter something like this, if we do not store this, we will not update here. Okay, so in that case, we will have the result as 0, where we actually want it to be 2. Okay, so we have to add this part. Okay, let me just use some asterisks to emphasize this part. Okay, yeah, after that it becomes pretty simple. Max length equals to 0, count equals to 0, and we will iterate through the nums length through the nums array. So count will we'll see nums I equals to 1. If it's 1, we will add 1. If it's not, we'll add -1. Okay, so that's it, and we will see if we have encountered the count before. Okay, so if map.contains key count, what do? We will update the maximum length. Okay, maximum length, and the maximum length will be I minus map.get this count. Okay, so it's exactly this subarray. Else, if we haven't seen that before, we will just put the count and the I into it. Okay, and we can just return the maximum length. Okay, let's see if it works. Yeah, this is pretty simple, and I will not say intuitive, but after some certain tricks, you will find it very familiar. Okay, so the time complexity will be O(n) because we're going to traverse the array once, and the space complexity will be at most O(n) because of the hash map. Okay, let's submit it. Perfect. It passes all the test cases. Thank you so much for watching. If you like the video and find it helpful, please like the video and subscribe to my channel. I will see you in our next video.